Yes.
Okay,
Yes.
got it. Okay. So hi everyone. My name, so like what Ivan mentioned, so is Dr. Miguel Martin. So it is my great pleasure today to be one of the first to basically be a speaker for this CCAI discussion series. So just to give you a brief, introduction of myself. So I'm currently a postdoc at the Delft University of Technology in the Netherlands, but I'm also a visiting scholar at Carnegie Mellon University, and I'm currently conducting some research supported by the European Commission. So today I was tasked by the CCAI community to discuss several questions with you. So the first one is more related to my past experience, which is essentially about, how we can use knowledge in computer science and physics to help solving some major challenges related to urban sustainability. Then I will also propose you to discuss some first, research I'm conducting in machine learning to be used for predicting outdoor conditions in an urban area in combination with physics. So then I will show you how we can use machine learning to calibrate urban building energy models to improve their reliability. And then there will be a last question, which I hope we can really discuss to find some possible collaboration as well, because this is really a topic that I just started, working on, which is the assessment of climate risk, using machine learning. So first of all, more of a topic which is related to my past experience and about myself as well, which is really the use of computer science and physics to study urban sustainability. So this is an item that will truly, I guess, represent, my whole career development and my whole career over the years, which is a pendulum. Because this is really the way I feel, over my career. I'm constantly switching from one side and the other and really asking questions of two of my best friends. So one of my best friend is Andy Royd, and this person is really an expert in AI and different, fields related to AI, and really helped me, understanding how I can really use machine learning for different purposes. And the other friend is named Albert, and this one is really an expert in physics and more specifically in all topics related to heat and mass transfer and fluid dynamics. So essentially, I did my master's degree at the University of Geneva, where I learned a lot of theories related to machine learning, image processing, robotics, and human-brain interface. And at that time, I was really wondering, based on this whole theoretical knowledge, how I could make a really good use of this knowledge and apply it to something which is really important for the world. And at the same time, I was, trying to study this whole, knowledge in computer science. There was a movie which is called Home, which was really important for me because it was really a movie showing all the impacts and all the negative consequences that climate change might have, in the future. And this is really at that time that I was really starting, trying to find out how I could use that knowledge in computer science to solve all the issues that were mentioned in that movie. So for that reason, I decided after to work at the EPFL, so the Polytechnic School of Lausanne, and start, understanding, how the energy is basically used in different sectors. So essentially, in the residential sector, in the industrial sector, also services and transport. And it is really during that experience that I found out that buildings play an important part in the whole, consumption of energy in a country and different countries. So for that reason, after I decided to move to the United Arab Emirates in an institute that at that time was called the Masdar Institute, which is now known as the Mohammed bin Zayed University of Artificial Intelligence. And it is really when I really wanted to learn more about how we can assess the energy which is consumed in a building. But for that, I really needed first to understand what is in the mind of an architect. And if you try to understand what is in the mind of an architect, first you have the notion of beauty. And I would say that most architects would say, okay, that's the only parameter that they consider. But I am a bit more of an optimistic person. And I truly want to believe that architects start also thinking about energy efficiency. But even when thinking about energy efficiency, there is really one aspect that they usually forget, is that a building is not just an isolated entity, but it operates in a whole outdoor environment and urban, environments. And this is, what I really wanted to start considering and see how the urban environment might affect, the energy consumption of a building. And for this, you need to consider several aspects. One is the roads, which are surrounding, the building. Also, the surrounding buildings that will also interact with the building that you are interested by. Also, the cars, because traffic releases heat, and this might also affect your energy consumption. And another aspect that is not very, important, to consider is the vegetation. Now, it's not only that those factors might affect, the energy consumption of the building, but in return, the building can also affect the outdoor environment through the consumption of heat or through the consumption of air conditioning. And this is all what I wanted really to consider. But for that, there is one thing which is really important. It is first to see how in a street canyon, the temperature and the humidity is affected by different factors. And those factors are, for instance, the heat and the water vapors that are emitted from your pavement. You also need to consider the heat that is released by the buildings that are delimiting your street canyon. Like what I was mentioning, traffic has also its importance, in the variations of the temperature and the humidity. And like what I was saying, your HVAC system will also release heat and water vapors that might influence the outdoor conditions. And like also what I was mentioning before, which is the heat and water vapors emitted by your vegetation. And this is all the things I wanted to consider to start, thinking about interactions between the building and its outdoor conditions. Now, I know that most of you are really computer scientists, and just to give you more of an understanding of how these, interactions can be implemented. So really the basics of an implementation of interactions between buildings and the outdoor conditions is described by this simple, diagram. So at the very top, you have a building energy simulator, which will assess the energy consumption of your building. And that can be connected through a middleware to an urban canopy simulator, which is basically the simulator that will assess for you the outdoor conditions. So usually what we use, it is a simulator, which is called Energy Plus, which really through a whole, graphical interface enables you to define the geometry of a building with a very high level of detail. And once you define the geometry of your building, essentially what you need to specify is some additional parameters that we will discuss later on to define, the different, aspects of your building and what also affects the energy consumption inside your building. And also, which is quite important, it is the boundary conditions of your building, which are usually measurements collected, from a rural station at certain points in the world. And once you define that, you can run, your simulation and get the assessment of your energy consumption and start, analyzing, the different aspects of the energy consumed by your building. And on the other hand, there is this urban canopy simulator. And at that time, I was essentially using what we call energy and mass balance models, which we also call RC models, because one thing that we try to do it is to reproduce the theory that we study, for instance, in electrical engineering or through an electrical circuit, and apply it to heat and mass balances to find out, what are, the outdoor temperature inside a street canyon. Now, I have to say, and to be very frank with you, as a computer scientist at that time, I couldn't fully understand the whole physics that was behind the thing I was trying to implement. And because I was a bit tired to be schooled, by experts in physics and heat and mass transfer, I really took a decision to learn more from my friend. Sorry, learn from my friend Albert and see, what physics, can tell me and enable you to improve the models that I was developing at that time. So for that reason, I decided to do my PhD at the National University of Singapore, where I tried to learn more about heat and mass transfers, fluid dynamics, and the meteorological experiments. And this really enabled you to improve the models, that I was developing, and essentially to understand how certain mitigation strategy could work, including cold pavement, vertical grain system, and also retroreflective facades. So then to my next topic, which is more something which is related to the project I'm currently conducting with the support of the European Commission. And one aspect of it is really to see how we could use machine learning to predict outdoor conditions. But first of all, just to ensure we are all on the same page, because I know that some of you knows the terminology of white box, gray box, and black box. And depending on the fields that you use this terminology, you might have different meanings. So especially when it comes to the assessment of outdoor condition in a street canyon, by white box, we essentially mean the use of fluid dynamics. So which is essentially a technique that enables you to see with very high resolution the airflow inside, a neighborhood and see, what are all the physical processes involved, in a street canyon. And this is really something that my friend Albert loves, because it is really something that he can understand the whole physics, which is happening, in an urban area. On the other hand, we have more of a black box models, which are more maybe models that which are more statistically based models. And those ones are really appreciated by my friend Andy Royd, because they can really easily be trained and tested with data. And in the middle, we have more what I was mentioning, the RC model, or the energy and mass balance models, which are both, appreciated by Albert and Andy Royd, because they can still, have some physical meaning, but at the same time, they can also easily be trained and tested, through machine learning. And this is something I will explain in the next slides. So as you can see, so far, I was essentially interested by the building scale. And now my current research really tries to extend, the scale of interest, which we try more to assess the energy consumption by a group of buildings at the neighborhood scale. And at the beginning, I was first trying to ask questions to my friend Albert. And one of the first suggestions that he made, why we don't use an energy and mass balance like what you did in the past. Now, the problem with these kind of models is that if you purely rely on physics, you will have, a limitation which is more related to the fidelity with which you can represent the urban morphology at the neighborhood scale. Now, of course, another solution would be to use computational fluid dynamics. But because, of course, it is a technique that tries, to represent all the physical processes with a very high resolution, it is also obviously something that will require a high computational cost. So for that reason, I was a bit stuck, in this aspect of physics. And I started to come back to my friend Andy Royd and see what are the suggestions he can make to improve, and reach, the goal, I'm trying to reach at the neighborhood scale. But for that, of course, my friend Andy Royd needs some data, of course, because without data, he can't really manage and can't really learn, new things. So one of the first, thing to think of, it is to install now a set of weather stations inside your street canyon, so that those data can be considered by my friend Andy Royd, and then, try to assess the different factors that will impact the outdoor conditions inside your street canyon. But this is not the only data that he needs to get, to come up with those kind of gray box models. The other data that we try to consider are more thermal images, essentially, to evaluate the land surface temperature. Also, some outputs that are provided by the building energy simulations, like what I did in the past, but also, some outputs from, like micro scale or meso scale weather simulations to know what are the atmospheric conditions. And based on those inputs, what we really try to come up is to generate an energy and mass balance so that my friend Albert can still, understand what are the physical processes involved in a street canyon. Now, if we want to go a bit more in detail, so if my friend Albert really want to understand what is occurring in a street canyon, he needs, to come up with differential equations. Now, I won't get really in the details of those equations. What is really important here is more to understand what is the physical meaning of the different parts of this equation. So on the left-hand side, we have more what is the heat and mass balance, which is stored by the street canyon. Then we have a very important part, which is the convective heat and mass transfer between the surface and the air volume. And I see that this part is very important because you have those H factors here, which are the convective heat transfer coefficients, which are the main variable that you need to optimize or to learn, from the equation. And then we have the sensible and the latent heat release by the traffic or your HVAC system. And from that, what we can see that this is essentially what we call a linear differential equation. And from that, my friend Andy Roy can come up with a linear state space, which can after be discretized and see, what is the conditions at different time steps of your simulation. Now, if we go more into the detail of that, so now considering the inputs that we can get, so the U vector of our discrete linear state space is essentially the inputs you can get from the different source of information. So first, you have the climate model that can provide the atmospheric condition, like what I was mentioning before. Also, your thermal images, which is essentially giving you the land surface temperature, and the building models that we essentially get the wall and window surface temperature and the sensible and latent waste heat releases. And from that, so now the challenge is essentially to find out what are the values for the different matrices to simulate, the outdoor conditions at different time steps. And for that, what we essentially use is a genetic algorithms that enable you to optimize the convective heat transfer coefficient so that you can find, an output that minimize the discrepancy between the measurements you are making at within, the urban street canyon. And from that, at the end, we can finally come up with, matrices that can be used to simulate the outdoor conditions at different time steps. Now, the relation between the building energy models and the urban canopy model is a bit more complex than just a relation between output and input. So what we really try to have is more of an interaction where the output of the urban canopy model are iteratively used also to improve the assessment of the energy consumption, which is made by the building energy model. And there are different ways, to couple this, with the urban canopy model. So essentially what we try to use is to use the weather file that is originally used by the building energy model that enables you to assess the energy consumption. Then we iteratively use the wall and window surface temperature, which is generated from the building energy simulation. Then we train the model like what I was mentioning before and iteratively try to modify the weather file that will give you, of course, other estimates, of the outdoor conditions. And we repeat this process until we reach a convergence of the energy consumption. So then one important aspect after is really to validate the model. And for validation, you need to use the weather data, weather measurements, and try to compare with the estimates of the urban canopy model. So for that reason, we are at Carnegie Mellon, we are starting, trying to deploy different weather stations to get those measurements and also, thermal images and compare this with also a true energy data to see the reliability of the model. And this environment will also enable you, to test a different scenario. So essentially the waste heat that is generated by the building, also what is, released by traffic, and what would be the extension and the effect of greenery, and also, what would be the effect of cool pavement. Okay, now so we come to our next topic, which is more on the part of calibration of an urban building energy model. And the first question we should first, think is why calibration is important. So when you want to assess the energy which is consumed by a building, there are different factors that are important to consider. One is the material, of course, to understand what is the thermal resistance of your building. Also, the windows are important. Also, what is happening inside your building. So how people, behaves and react, inside the building. Also, the artificial light, and also, the different aspects of the electricity which is consumed by different devices. And all these different factors enables you to generate, essentially a building energy model. But now what happens is that despite the importance of those factors, there are always a high uncertainty in their definition and true value. So for that reason, one of the first questions we should ask before even calibrating the model, it is what are the parameters that will significantly affect the energy consumption of the building. So once we define, the different parameters we want to calibrate, first we need to generate different samples that relate certain values for our certain parameters and what we call the goodness of fit between the true values for energy data and what is estimated by your building energy model. Now, because, the building energy model is still, more of what we would consider a white box model, it might, be very time consuming to explore the whole set of possibilities. So for that reason, from the sample that are generated, we usually try to come up with some surrogate models that then will be used, to optimize and find, the optimal solution that will minimize the discrepancy between the true energy data and the estimated data. So once you have that, so you can come up with a building energy model. But one thing that we observe in the literature is that despite we want to evaluate, a cluster of buildings, actually their interactions with outdoor conditions were essentially ignored, so far. And this is one question I try to solve, which is essentially trying to include, the couple scheme, I developed, and I was describing before. What would be the impact on the whole, procedure of calibration of considering an uncoupled or a coupled, model. So for that, as first we need to understand what is the goodness of fit. So I essentially use a metric which is quite common and well defined in some standards like ASHRAE to determine what is the discrepancy between the actual consumption and the one which is, estimated by the model. So first, in terms of sensitivity analysis, what we observe, considering different, parameters. So you can see parameters that are more related to what we call the internal heat gains, also the thermal resistance of the wall and the thermal resistance of windows, and some aspect of the infiltration. One thing that would be commonly, believed is that those that are related to internal heat gains, will have a high impact, on the goodness of it, which is actually something which is true if you consider, the uncoupled situation. But another thing that now we observe is that if we consider the coupled situation, other parameters like the infiltration that directly connects the outdoor to the indoor, and also other parameters which are more related to the thermal properties of the wall will have a higher impact on the goodness of fit when you consider the coupled situation. Then we also try to observe, how the whole distribution of the goodness of fit is affected when you consider the coupled and the uncoupled situation. And for that, one thing that we observe is in the case of calibration, the probability to find an optimal solution is divided by 2 when you are basically coupling your model with the urban canopy model. And then another thing that we realize is having like a linear regression analysis. So considering this variable, which is C, which is a dummy variables, which says that we are using yes or no, the coupled or uncoupled situation. We observe that by coupling this model to the urban canopy model, we might increase the goodness of fit by 20%. Which means that in a situation that you might believe that your model is calibrated, it is actually not if you compare, if you are more considering the interaction between building and the outdoor conditions. Okay, so this is something that still it is in progress and essentially where I'm also looking for collaboration. where we try, to determine, how, the accuracy of the surrogate models might be affected if we use uncoupled or coupled situations. And also, in terms of optimization, how the uncoupled or coupled situation will affect the final solution that you might get out of the calibration. Okay, so now we come to the last topic of this presentation, and before, our discussion. So I know that climate risk assessment might have different interpretations. Now, the way we interpret, climate risk assessment is more related to a phenomenon that we call the urban key talent effect, where it is essentially described, as temperature differences between what happens, in the center of a city and the rural surroundings. And what we really want to see it is the evolution, of this phenomenon, over an horizon of 20 to 30 years, and see what could be the impact in terms of energy consumption, also, the emissions of greenhouse gases, and ultimately to see how this might affect, the maintenance of your HVAC system, and also how it can be of a issue, especially in north regions of the globe, for public health, essentially during the heat wave episodes. So again, just to brief you, on the terminology, what we mean by white box, break box, more in the building energy model aspect. So as you might easily guess, white box is what we call the detailed building energy model. So this is usually what we come up with Energy Plus. Black box will also be, something that we use, a different statistical model to evaluate the energy consumption. And the gray box will be a RC model, but which is now applied to the building and the indoor conditions of the building. So now the intention that we have is, given, the projection we can make on the outdoor temperature in an urban area. So instead of, using our calibrating model, which is still, having, require some computational, resources, we want to see how we can infer a full gray box model to simulate the interactions between the buildings and the outdoor conditions. And then from that, it is essentially, the aim is it is essentially to introduce in our all couple scheme, the RC model, so the gray box model, which will be trained, in the same, framework, but based on the data that are provided by our calibrated model. So the other aspect is that instead of just considering outdoor humidity and temperature in a street canyon, we also want to include, the CO2 that is released by traffic and the building, and also some pollutants that are, for instance, the well-known PM 2.5. So then from that, what we expect, it is essentially, from this coupled scheme to see, what is the evolution of the urban heat talent over a horizon of about 20 years. Which will enable you to essentially, foresee, what would be the impact on energy consumption and the release of greenhouse gases. And then, what could be, the impact on different socioeconomic factors, and see what is the evolution over the years. Now, to be frank with you, here we are really, into the methodology more than the interpretation. And definitely, currently, I'm trying essentially to build, some collaboration with some researchers that are really have more knowledge onto the socioeconomic factors that will enable me, to predict, the different, impacts, in the future using the model I use. Now, another thing is that even though we have a model that can potentially, predict, the urban heat talent over a horizon of 30 years, this model still relies on some inputs from different sources. One, which is the atmospheric condition provided by a climate model, and the other one, which is the land surface temperature. And this is also something that I really hope, I can find, some scientists or even people from industry that can enable me, to really understand what are the potential predictions that can make over the year, and see how this, can improve the model that I'm currently developing. Yeah. So this is about the end of my presentation. Yes, so so if you want to learn a bit more about my current research, and my CV, so I can invite you, to my website, which is miguelmartin.org, or you can also, find me, on LinkedIn. And I guess I'm perfectly on time because it is about 30 minutes. So I'm very happy, that I hope that this presentation was of interest to you. And I really hope, for a very fruitful, discussion now, and hope for future collaboration. So thank you very much. Yeah.
Thank you very much, Miguel. So before we enter to different breakout rooms, if there's any questions that you would like to ask Miguel or Dr. Martin, please feel free to do so. We probably take a few questions before going to the breakout rooms. And I personally like how you differentiate which one belongs to physics and which one belongs to the machine learning by using the icons of your two good friends like Albert and also
Andy Roy.
the Andy Roy. Yeah. So you can unmute yourself, either unmute yourself or you can actually type your questions in the chat room. So yeah, just. Okay, so there is a question about what type of collaborations are you looking forward to?
So essentially, for the moment, there are two kind of collaboration I'm really, looking for, which is essentially related to my postdoctoral fellowship, because what the European Commission wants me to do is first to disseminate my research through academia. So essentially, so this is more of collaboration between scientists. But another important aspect would be to exploit, my research in industry. So essentially, I'm also trying to look for some people in industry that will enable me, to understand how this research can be of their use or their interest. So actually, I'm looking for both, can be academia or also industry. So does this respond to the question of the person who asked the question?
Okay, sure.
Okay.
So maybe yeah, one more question before going to the breakout room. So can you see the question what types of methods are you using to I guess it's the type of algorithm you choose, I guess.
For which part?
She mentioned about the reliability of the energy models. So
Okay, so more the calibration, no? So for the calibration part, I guess, no? So essentially, I mean, for the moment, we attempt, to use quite, I would say, standards or well-known black box models that are presented in the literature. For the moment, we don't really try to innovate, in the aspect of black box modeling. It is more first, to understand using standards methods, what would be the impact of considering interactions between buildings and the outdoor conditions or not, So basically, here we really try to find out what the current state of the art is missing by considering, urban building energy model with isolated models. This is first what we try to do. Now, of course, there is also an aspect that we are also interested in the future. It is to find out what are, modern, more modern black box model we could use to improve the calibration of urban building energy model. And this is really something that I also started, try to look for collaboration for researchers who have more knowledge, on surrogate modeling and see how this, can improve the calibration of urban building energy model. Yeah.
Yeah, Dr. Miguel, this is Samrat from GIZ, and I was looking forward to collaborate with you. I'm working in the industry in the development cooperation sector. How can we collaborate using this data and research?
So essentially, the point of collaboration would essentially be, like what you mentioned, so based on certainly, some data that you have, see, how we can assess, the outputs that could be of your interest. The thing that we try, to develop here is methods that can easily be integrated into what we call city digital twins. So by city digital twins, we essentially mean, like a virtual replicate of a city that would enable architects and urban planners first to see the operation of the city, but most importantly, to test mitigation strategies and strategies, to improve, the urban environment. So what I really want to know from industry is how I can help them or use, my methods for developing better tools and to improve, the reliability of the decision making. So Samrat, does this respond to your question or?
No, I asked like, how do we move forward? Like, what's the method of collaborating?
You mean from
we go forward?
from an administrative aspect. So this is what
Yes.
Okay,
Yes.
okay. I mean, for the moment, yeah, I mean, I'm totally, so this, I would say this truly depends, on, how can I say, also what are, your, what your administration might require, because from my side, yeah, definitely I have a high support from the European Commission to exploit my research. So definitely, the European Commission would be more than happy, for me to start, collaborating, with industry. Now, to be frank with you, I might need, to have a bit more, discussion maybe with you in private to understand what are your requirements or what you might expect from the research and see how we can, because to be frank with you, I had several attempts so far with industry. But somehow, I found some difficulties, to get the collaboration started just for administrative reason and maybe for the business model. Yeah. So for that, yes. So please just contact me by LinkedIn or by email. So I think you might have your email so that we can have more of a private discussion to see how we can start collaborating. Yeah.
Okay, I'll send you a LinkedIn request and
Okay.
Thank you very much. Because of the time constraint, I guess we need to enter the breakout rooms. I mean, I do appreciate if you can actually, continue to ask. Miguel will be in different breakout rooms. I noticed that there are a few very good questions being asked, like including whether the satellite data and also, the passive heating and yeah, when Miguel comes to your breakout room, you can actually, ask them. So yeah, I will create 3 breakout rooms.
So I have to say stop and join. This is what I have to do, Ivan.
Yeah, currently I think it's like they have yeah, they should be like 15 to 13 people among inside the room. So maybe each join one room. Miguel, you join room 1, I join room 2, and Rasika join room 3. And then Miguel, you can actually join us the other 2 rooms later.
Okay, sure.
Can we do that?
Yeah, we can do that. Yeah. So
sorry,
stop
I
and
forgot. Rasika, you are going to room
3.
Okay, I'm going to 2. All right.
All right.